Okay, Pythagoras' theorem, so we've seen this lots of times, right? But just run through a few questions here so we can check that we fully understand it. Of course, with Pythagoras' theorem, you might have learned this formula, c squared equals a squared plus b squared. Okay, so we're squaring every side of the triangle, okay? And the square of the two shorter sides, these are the two shorter sides, the square of them, when we add up the square of them, it will give us the square of this side. Of course, this is my C, right? This is my C. That's my longest side, because it's opposite the right angle. Okay? And yeah, all we need to do really is square these sides, and we're on our way. So basically, in this case here now, I'm going to do C squared. Okay, that's what I want to work out in this case. C squared will equal, now it doesn't matter what you call A, right? You can call that A if you want, and that B, 7.1 squared plus 3.4 squared, okay? And then it will help us then with working out C squared. So on my calculator, 7.1 squared plus 3.4 squared, press that button there, 61.97. Okay, and of course then, that's what C squared is equal to, that's what the square of the longest side is equal to. To actually work out C, I've got to take the square over to the opposite, square root. Okay, so square root that answer there, and I get my answer then, 7.87, right? So, you know, I might write all of that down to a few decimal places. What I would probably do then is, I would probably round that to one decimal place. So we've got there, what have we got there? It's a 7, so that becomes a 9. I'm rounding it to 1 simply because they've got one decimal place here in the question. Okay. Right, second problem. Okay, this looks a lot more complex, but again, it's just Pythagoras' theorem. They're asking us to work out side AD. Okay. Now, I hope you could notice here, we've just got two triangles, haven't we? Two triangles. And usually when they have questions involving two triangles, you have to work out something on the triangle that doesn't involve the answer. So if you look there, we want length AD, don't we? So that involves this triangle. So usually when we ask for something on this triangle, we need to work out something on the other triangle first. And if you look at the other triangle, notice here, right angled, we've got those two sides, we just need the longest side here. This is the longest side, isn't it? Because it's opposite to the right angle. So that would be our C in that case with this triangle. So quite simply again, C squared equals 8 squared plus 6 squared. Okay, so you work that out, that becomes 100. And then C is the root of 100, which equals to 10. Okay, so we know that's equal to 10. And what's great then is when you move over to this triangle then, you could see, okay, it's sort of rotated round, but you've got yourself, again, right angle triangle, and we know the two shorter sides. In this case, this is a shorter side of this triangle, because if you notice now, there's your right angle, so opposite it is your hypotenuse there, so we can call that C in this case, right, in the second triangle. So with the second triangle then, we'd have C squared equals 5 squared plus 10 squared. Okay, so you work that out on your calculator, that becomes 125, and then C will be the square root of 125. Okay, and that becomes 11.2 if I round that to one decimal place. Okay. Right, second situation, quite wordy up here, obviously you need to read it, I've read it already. Quite simply, if you look closely, they're asking for the height, yeah? They say calculate the height, TR, that's what they want, the height there. The top of the ladder above the ground, so we've got a situation here where a ladder is resting against a vertical wall, okay? But they're asking for the height, TR, it's simply a right angle triangle again, look, okay? Pythagoras' theorem, okay? And they want TR. Well, what I want you to notice in this particular case, obviously, this time we're given C, aren't we? We're actually given the longest side. That's the longest side, isn't it? Opposite here. Okay, so when we use Pythagoras, okay, c squared would be 6.3 squared, that would be 3.7 squared, and in effect we want like b, if we call it b, we want b squared, don't we? So in effect I'd be calling that b, I want b there. Now to get b squared, I need to get b squared in its own, so I need to take that 3.7 squared over the other side. So this time, of course, I'm taking away the squares, right? I'm taking them away. So I get that, and that comes out to be 26, okay? So 26 equals b squared. And to get b then, all I've got to do, of course, is take that square over and square root. So square root my answer, and press the SD, I get 5.0990 blah blah blah. Okay. If we go back to question, right, in this case, you've got to be careful because it does say give your answer to an appropriate degree of accuracy. Okay. Of course, appropriate degree of accuracy is just look at what they're measuring here, 1 decimal place. So I need to write this to 1 decimal place. So I need to chop all this off. And because that's a 9, I round that up to a 1, so 5.1 meters. Okay, last situation, this is interesting here, right? Because here, I mean, we'll read it. So Alwyn is a carpenter. He normally uses a tool called a tri-square to measure angles of 90 degrees. One day, Alwyn forgets to pack his tri-square. In his van, Alwyn has 3 wooden rods of length 8, 15, 17 centimeters. Show using calculations that you can create an angle of 90 degrees by joining the ends of these rods to form a triangle. So he's forgotten his tri-square. What they're saying is you could actually, with these rods, you could actually make sort of a tri-square. You could make a right angle triangle. Okay? And really all you've got to do with this case here is just show that Pythagoras' theorem actually works for this. What I would do is just draw a little sketch of a triangle, okay? It's not difficult. Okay, you can see this is a proper sketch here because I only used a ruler. But that would be my 90 degrees. And then you've got to think, well, what about these sides here? Okay, I've got 8, 15, 17. Well, 17 should go there, shouldn't it? So that's the longest side, 17. Okay? And then here and here, it doesn't really matter. 8 and 15. Now, if Pythagoras' theorem works, then we've shown that that is a right angle triangle. Let's try Pythagoras' theorem. Okay, so we know Pythagoras' theorem is this. Let's see if it works here. We've got 8 squared and 15 squared. Let's see what that becomes. Okay, so work that out on my calculator. 289. And of course, what we usually do then to get c, we square root, don't we? So let's square root that. Square root the answer. And look what I get. I get 17. Pythagoras' theorem works. So we can say that. Pythagoras works. That means it is a right angle triangle. Okay? So we can create 90 degrees.